Hello everyone, this is Parushuram, faculty of CSE, Ravindra College of Engineering for Women. In this session, I would like to explain about Software Project Management, Unit 1. Software Project Management. We'll discuss about the old way here, waterfall model, conventional software project management performance, followed by evolution of software economics. In that evolution of software economics, we will learn about software economics and pragmatic software cost estimation. The old way, software plays a very important key role in the human life. The best thing about a software is its flexibility. So when you talk about flexibility, we can do almost everything. A software can be programmed to do almost anything. That is about best thing of a software. The worst thing about a software is also its flexibility. So how we can justify that point? The almost anything feature has made it difficult to plan, difficult to monitor, and difficult to control the software. So the waterfall model, the very old model, this is a process model which will tell you how to proceed with the software development. So initially we go with the system requirements, followed by software requirements, analysis, program design, coding, testing, and finally maintenance and reliance. So this is what happens with the software development process. So this is a process model. So what is my process model here? A process model will tell you how to develop a software. So this is a diagram which is called as waterfall model, the very first process model for developing software. So once again, let me get you clearly what are the steps to be followed here. System requirements, software requirements, analysis, program design, coding, testing, and maintenance. System requirements. In this step, we will define the overall system goals, scope, and hardware needs. So mostly we will try to gather the hardware requirements in the first step. Second one, we have software requirements, specifying the detailed functional and non-functional requirements of the software. So we will try to gather the software requirements here in the second step. Third one, we have analysis. In this step, study requirements to check feasibility, nothing but financial feasibility, time feasibility, and effort feasibility can be assessed here in the analysis step. So that is done in the third step, followed by constraints and solution approach. So this is what is called analysis. A complete feasibility approach can be found in the third step called as analysis step. Program design, the fourth one, create the system architecture, data flow, and module design. This is nothing but its complete flow chart or a complete pictorial diagram that will tell you the entire software development. So that's a pictorial representation. This is program design. So create the system architecture, data flow, and module design. Next we have coding part, converted the design into executable source code. Code is the main backbone of the software. Next, followed by testing part, verify and validate the software to find and fix defects. This step is used to identify the errors in the code and errors in the program design. So testing plays very important crucial role after followed by coding, verifying and validate the software to find and fix the defects. And last one, maintenance and reliance, update, improve and support the system after deployment. So once your deployment is done of the software, then we will try to update and improve the performance of the software. So this is what is called waterfall model. Let's get back into details once again. The steps which we followed in the waterfall model: system requirements, software requirements, analysis, program design, coding, testing, and finally maintenance and operations. System requirements will define the overall goals, scope of the project, whether we can do it or not. Hardware requirements, what are the basic hardware requirements that are required here. Second one, software requirements. This will tell you about detailed functional and non-functional software requirements. Analysis part, which tells you about financial and time feasibility, whether the product which we are going to develop can be feasible or not. Next, fourth one, we have program design. Creating the system architecture is the main part. In this part, the program design will tell you the pictorial representation of entire software development right from inception phase to final phase. That is about program design. Coming to fifth one, coding part, convert the design into executable source code. We have got so many tools for writing the code. Testing part, verify and validate the software to find and fix defects. Maintenance and reliance. So this is what is called waterfall model, the very oldest way of developing a software. So there are some drawbacks with the waterfall model. Integration, late design breakage, late risk resolution, requirements driven functional decomposition, adversarial stakeholder relationships, focus on document and review meetings. So there are some drawbacks, these are to be overcome with some other advanced process models. So what happens with the old way? Let us see some drawbacks with the oldest way process model. Finding and fixing the software problem after delivery costs 100 times more than finding and fixing the problem in early design phases. After delivery, finding and fixing is not a suggestible point regarding the error correction or any software problem identification. That should be done at the initial phase itself as per the point. You can compress software development schedule 25% of nominal but no more. So the entire process model, which will take some schedule or some time, the time can be compressed here, but up to only 25% by using these conventional process models. But coming to the next point, for every $1 you spend on development, you will spend $2 on maintenance. So when there is a software or there is a product in your hands, so there is a cost accomplishment, but for every $1 you spend on development, development cost rather than development cost, maintenance cost is more, maybe getting doubled. Okay, that is what happens with the third point. Software development maintenance costs are primarily function of the number of source of lines of code. So when you go for software development, coding plays very important crucial role, mainly focusing on development maintenance costs, which are major functions here. Fourth one, and coming to fifth one, variations among people account for the biggest differences in software productivity. So when it comes to this point tells about some kind of differences or some ego problems between the people, which has got some direct impact on the software productivity. So there is a mapping for this one. So like here, all the people who are working together must work with the teamwork. Okay, and there should be good coordination, cooperation among the people, so that there can be efficient outcome regarding the software development. The overall ratio of software to hardware is still growing. In 1955 it was 15 to 85, and in 1985 it was 85 to 15. So if you observe this point, software to hardware in 1955 development of a software was only 15%, but there was much concentration on development of hardware. See that statistics over there, 85% on hardware. But in 1985 until today also, the figure got changed completely, and it is completely reversed, 85 to 15. So more concentration, more hard work, and more focus on the software development is done today rather than hardware. So plays very important crucial role. That's about statistics here. Only about 15% of software development effort is devoted to programming. So remaining 80% can be focused on some other aspects like productivity, maintenance, estimation the feasibility, designing part, requirements part. That is about remaining 85% part, but only 15% is software development effort is devoted to programming today. Not only 15%, this figure can come down to 5% also as per the tools available today. That is one more point. Walkthrough catches 60% of the errors. Here walkthrough is nothing but identifying the errors and any problems by human thinking without any usage of tool. That is one more point. So 80% of contribution comes from 20% of contributors. Less number of contributors are there, but we'll do more contribution. That is this point. See, if you observe this point here, 80% of contribution coming from 20% of contributors. So evolution of software economics. Coming to next point, we have evolution. So most software cost models, here cost model is nothing but process model. So most software cost models can be abstracted into a function of 5 basic parameters. Size, typically number of source of instructions we write, I mean to say in terms of SLOC, source lines of code. Process, the ability of the process to avoid and non-value adding activities. Process model which you are choosing will be very important for developing a software or a product. So that's why process plays very important key role. Next one, personal experience with the computer science issues and other application domain issues of the project. When whatever the persons who are involving in the project development, right from inception phase to ending phase, their experience must add the value to the development of a project. So computer science issues or any application domain issues, so they must be aware and they should be able to solve that one. That is the third one. Next one, environment. What kind of environment should be there, and tools and techniques available to support the efficient software development and to automate the process. Very important. Environment also plays important key role, where all the tools and techniques which are available to support the project development can be done. Quality, with respect to all remaining aspects what are learned today, quality plays very important crucial role, because the ending outcome should have efficient performance, reliability, adaptability. Performance metric is very important, how that product is performing when it is into the beneficiary hands. Reliability, how reliable the product is, that should be assessed here. And adaptability, any product which we are delivering to the beneficiary must be able to adapt to all kind of environment. It may be software environment or hardware environment. The product must be able to reach every community. That is what quality here. Thank you.